Namaskar students. See this, in this today's live lecture we shall study the next part, that is a Lagrange's equation of a motion for the compound pendulum. Here in the last lecture we have studied the Lagrange's equation of the motion for simple pendulum. Then also we have studied the Lagrange's equation of a motion for the Atwood machine. This is the particular type of a machine. Now today we shall discuss the next important equation, and that is a Lagrange's equation of a motion for compound pendulum. Compound pendulum means actually, if suppose a rigid body making an oscillation is like a pendulum, then each and every particle of that pendulum goes on oscillates. Each and every particle goes on oscillates. So this type of oscillation is called as a compound pendulum. See this, you must know. The term you must know what is the meaning of the compound pendulums here. Then we shall discuss the equation of the motion of the compound pendulum. Actually there are three important problems. First problem is find the Lagrange's equation of a motion for simple pendulum. This is one important problem. Find the Lagrange's equation of a motion for Atwood machine. And third, which we have to use, find the Lagrange's equation of a motion for compound pendulum series. Now these are the relations already you must know. I shall revise every day this basic part because you must know all these things. That is generalized coordinate, generalized velocity, virtual work done, that is principle of virtual work done, D'Alembert's principle. Then Lagrange's equation of a motion in first kind, Lagrange's equation of a motion in second kind, that means in the conservative system, which is in the form of a Laplacian. So today we shall discuss the next concept, that is the concept regarding Lagrange's equation of a motion for compound pendulum. Question is that, see here, the question regarding this is, what is that question here? Find the question. Find the Lagrange's equation of a motion Lagrange's equation of a motion for compound pendulum. Actually there are three different types of problems which may ask on the pendulum, that are simple pendulum. Second is double pendulum. If two balls are attached one after another and the oscillation is considered with respect to both the balls, then that is called as a double pendulum. And third is a compound pendulum. Compound pendulum means suppose a rigid body is going to oscillates. Rigid body is oscillates at some particular, about some particular fixed point. Then such a type of a pendulum is called as a compound pendulum. See this, suppose this is a rigid body. If this rigid body oscillates, then each and every point is going on oscillates as like a bob. So this type of a mechanism is called the compound pendulum. So now we shall find the equation, Lagrange's equation of the motion for a compound pendulum. Before this, first of all, we shall draw the diagram. Suppose this is a rigid body. If this rigid body is oscillates about this point, suppose fixed point is this O, and this body is oscillates in this way, okay, then each and every point is going to oscillates. Each and every point is going to oscillates. If we consider this point is, suppose this point is, suppose C, the oscillation of this point is, suppose we can write this point is, suppose capital A, this point is, suppose after the oscillation, that is a C, okay. Then the height of this is to be considered as a oscillation, that is H, this is a L, which is approximately given by theta. So height of the pendulum. So height means, which is L, we can take L cos theta. Okay, no problem. This is suppose x axis. So this, okay, this gives theta, deflection theta, the moment of inertia which is considered as a fixed L. So we can take the point here mg, this point is, suppose we can consider this point as a, suppose C, whatever may be, you can consider any point. See this, the oscillation of the rigid body is about this fixed point. This is the total fixed point, suppose, okay. So ठीक है, this is suppose x axis, this is a suppose y axis. Now we shall write what is mean by the compound pendulum. First of all, discuss what is mean by the compound pendulum. Then we shall explain the equation of motion. A rigid body is capable of oscillating in, a rigid body is capable of oscillating in a vertical plane, above a fixed horizontal axis. Above a fixed horizontal axis is called compound pendulum. See this is the concept of a compound pendulum. You must know what is meant by the compound pendulums here. A rigid body is, see this, suppose any rigid body, it is capable to oscillate about some fixed point, So each and every point of that rigid body is oscillating as like a bob. So it has a n particles, so n particles are going to oscillate, so it is called as the compound pendulum. Fixed horizontal is called as a compound pendulum. Let now see this, let a vertical plane of oscillation vertical plane of the oscillation B.Sc.Y. B.Sc.Y. See this vertical plane of the oscillation B.Sc.Y. plane. In that XY plane, we consider the rigid body is going to oscillate, okay, XY plane, and O is the fixed point, and O is the fixed point, through each of the axis of rotation passes, through which the axis of rotation passes. See this. काही तुम्हाला प्रॉब्लेम आला, मोनिका पवार, शुभम जंगम, मोहिनी काळे, भाग्यश्री नाडे, if you have any doubt then you can ask. Let C is the center of a mass. Suppose let capital C, see this, if we consider C be the center of mass, कुठं का अशाना center of mass, we consider the point C. हा point P consider करा इथं. So we consider a point P and C be the center of mass at which we can write. ही theory वेगळी आहे. Let C be is the center of a mass and M be the mass of pendulum, mass of a particle P or pendulum, mass of a pendulum, that is a particle at P, mass of a particle, because we consider the particle P is going to oscillate, only that point is, suppose we consider M. Now see this, let M be the mass of a pendulum or at a point P, the moment of our inertia, let the moment of inertia about the axis of a rotation is, suppose I. If we consider the moment of inertia I, the distance between the point O and C is, suppose L, the distance between the point O and C is, suppose L. O and C suppose L. If we consider the L, let theta be the angle of deflection. Let theta be the angle of deflection of the compound pendulum. Then we know that the kinetic energy of the compound pendulum is given by, so therefore kinetic energy 1/2, actually M.V.² असतो, but it is the moment of inertia. In terms of a moment of inertia, I into theta dot square. Suppose if we consider this equation 1, so the potential energy relative to the potential energy relative to the to a horizontal plane, is given by, actually potential energy, formula for the potential energy is mgh, but this height can be measured, this height can be measured in terms of theta, that is L into cos theta. Suppose L is the hypotenuse, then it is given by potential energy which is equals to mg minus means which is opposite to the gravitational force of attraction, mgh, but h is L into cos theta. Suppose this is equation number 2. Now we know that the Lagrange's equation of the motion is, we know that, what is the formula for the Lagrange's equation of motion? Student, you tell me. We know that Lagrange's equation of a motion is, what is that formula? That is d by dt of dou L divided by dou, here theta is the generalized coordinate. Here theta is the generalized coordinate, therefore we have to write the Lagrange's equation of a motion in terms of generalized coordinates. So we can write theta dot minus dou L by dou theta, which is equals to 0. Suppose this is equation number 3, where L means the Laplacian which is given by t minus v, but we know that the value of t is 1 by 2 I into theta dot square minus mgl into cos theta. This is a from 192. This is from 192. That means from kinetic energy means T, potential energy means V. So we have to write T minus V. That means we can write this as 1 by 2 I into theta dot square minus plus mgl into cos theta. So this is the Laplacian L. Suppose this is a 4. But to find the Lagrange's equation of a motion, we have to take dou L by dou theta dot and dou L by dou theta. So differentiating equation 4 with respect to theta dot means we have considered the differentiating parameter, that is a differentiating variable, as a theta dot. So dou L by dou theta dot which is given by, see this, only we have to differentiate with respect to theta dot, means theta dot is a variable, remaining terms are said to be constant. So 1 by 2 is a constant coefficient. Here I is moment of inertia, which is also constant coefficient because which is given in the product of theta dot. So 1 by 2 is it is, I is it is. Then now you tell me, the students, what is the formula for derivative of theta dot square? That is a 2 into theta dot plus, now if we differentiating partially L partially with respect to theta dot, then theta is also considered as a constant coefficient. So m is a constant, g is a constant, L is a constant, and theta, cos theta will be also constant. So total these quantities are constant. So its derivative is 0. So its derivative means mgl cos theta का derivative होता है 0. So the final value, that is dou L by dou theta dot, which is given by 2 will be cancelled, I into theta dot. Okay, so we consider this equation as a 5. Very good, Anita Rajmane, very nice. Also differentiating, because see this, for the Lagrange's equation of motion we need dou L by dou theta dot and dou L by dou theta. So already we have calculated dou L by dou theta dot. So again we have to calculate dou L by dou theta. Equation 4 नुसार dou L by dou theta काढा. Student सांगा रे. Now you tell me, Wade, Saurabh Wade, you tell me what is the derivative. All students should tell what is the derivative of L with respect to theta. That is a partial derivative with respect to theta, means dou L by dou theta. इसका डेरिवेटिव निकालना है. डिफरेंशिएटिंग इक्वेशन 4 with respect to theta. So we write dou L by dou theta, which is equals to, see this, if we differentiating with respect to theta, then only theta is considered as a variable. Remaining all the parameters are said to be constants. All the remaining variables, all the terms are said to be constants. So in the first part, see this, in the equation of L, in the first part 1 by 2 into I into theta dot here, 1 by 2 into I into theta dot. So 1 by 2 is constant, I is constant, theta dot is constant, because we are taking a derivative with respect to theta. So the total terms are constant, so its derivative will be 0. Plus, now we consider the second part, that is mgl cos theta. In that mgl cos theta, theta is a variable. Now, for in this case, theta is a variable. So m is in the product with theta, g is also in the product with theta, L is also in the product with theta. So they are considered as a constant coefficient with respect to theta. So keep it as it is, mgl. Now see this, then the derivative of a cos theta is, 1 minute students, one minute, sorry. Derivative of cos theta is again a minus sin theta. So dou L by dou theta, which gives us a mgl minus mgl into sin theta. Suppose this is a 6. So put the values of equation 5 and 6 in the Lagrange's equation of motion. So putting equations 5 and 6 in, suppose that equation is 3, that is d by dt of dou L by dou theta dot minus dou L by dou theta, which is equals to 0. So d by dt of dou L by dou theta dot means I into theta dot minus dou L by dou theta means, which we have calculated, minus mgl into sin theta, which is equals to 0. So minus minus will be plus. So d by dt of I into theta dot plus mgl into sin theta, which is equals to 0, Now we can take the differentiation, ordinary differentiation of a first bracket I into theta dot, because theta is the, theta dot means it is the term of t, d theta by dt means theta dot. If we take again derivative of that, then we can write this as I into theta double dot plus mgl into sin theta, which is equals to 0. So we can write theta double dot dividing by I into mgl divided by I into sin theta, which is equals to 0. But note that if deflection is a very small, if deflection is a very small, if theta is a very small, if we consider the deflection is a very small, that means theta is a very small in the radian system. You note that the value of a sin theta, very good राजमाने, मायनस राहिले का आपलं काही, भुजबळ गजानन भुजबळ मायनस राहिले का? ओके, बरोबर आहे ना? इज इट ओके? काही विसरलं का? विसरलं असेल तर सांगा. So if deflection is a very small, that means amplitude of oscillation is a very small, then value of a sin theta is approximate equals to theta in the radian system. You note that. So I shall write this: if amplitude of oscillation is a very small, then sin theta is approximate equals to theta. So we can write, therefore the equation of a motion becomes theta dot plus mgl divided by I into theta, which is equals to 0. So this is the equation of the motion. So this is the equation of the motion, Lagrange's equation of a motion of the compound pendulum. So this is the required Lagrange's equation of a motion of a compound pendulum. Okay, and hence we can prove this. So see this is the complete part of the problem. So we can write this. अशा पद्धतीनं हा complete problem oscillation चा part आहे. So we can write this center S, C, L, whatever may be, we can write this C point B असेल, काही अडचण नाही आहे. So this completes the oscillation. O means fixed point. Here O is the fixed point. आता इथं तुम्हाला ॲक्सिसचा O वाटत असेल तर इथं तुम्ही बदलून घेऊ शकता, काही अडचण नाही. एक्स ॲक्सिस वाय ॲक्सिस दाखवावंच असं काही नाही, तुम्ही नाही दाखवलं तरी चालतं. So we can write this as O dash. So we can take O dash, no problem. एक्स ॲक्सिस वाय ॲक्सिसच पाहिजे असं काहीच नाही, तुम्ही एक्स ॲक्सिस वाय ॲक्सिस नाही लिहिलात तरी चालतो. बट ओके, आय शॅल रिमूव्ह दिस. Not necessary, you can write or not, you don't write, no problem. This is the horizontal axis. We have considered only the XY plane. आपण हा काय दाखवण्यासाठी घेतला होता, म्हणजे हा जो ऑसिलेशनचा पार्ट आहे ना, तो एक्स आणि वाय प्लेनमध्ये आहे दाखवण्यासाठी घेतलं होतं. रफ आयडिया. ओ मे बी हिअर, इथं सुद्धा ओ असेल, काही अडचण नाही आहे. वी हॅव कन्सिडर द एक्स वाय प्लेन मीन्स व्हर्टिकल ऑसिलेशन. ओके, नो प्रॉब्लेम. तर प्रॉब्लेम समजला का रे तुम्हाला? सूर्यकांत वाघे, वैशाली पवार, पूजा आटोळकर, गजानन हिंगमिरे, ऋषिकेश उदगीरकर. हां, तर प्रॉब्लेम सर्व समजला ना तुम्हाला? ह्याचं सोल्युशन सी दिस इज व्हेरी इंटरेस्टिंग प्रॉब्लेम. that is Lagrange's equation of a motion of a compound pendulum. If a moment of inertia is I, then the kinetic energy which is denoted by T in terms of a moment of inertia is given by 1 by 2 I into theta dot square. Actually you know that the potential energy means mgh minus mgs because it is in the opposite direction of gravitational force of attraction, so we can write mgh, but h is given in terms of length L cos theta, so h is replaced by L cos theta. Then we can write according to the Lagrange's equation of the motion. Here theta is a generalized coordinate, you must know. So the Lagrange's equation of motion in terms of, why we can say that theta is here, why we can say that theta is a generalized coordinates, because at the time of oscillation theta is going continuously changes, increasing, decreasing, increasing, decreasing. So theta is continuously changes, remaining terms are constants. L is a constant, mass is a constant, g means the gravitational force of attraction is a constant, moment of inertia is also constant. So all these terms are constant, only the theta is a variable, that is a motion is a depend on theta. So theta is a generalized coordinate here, and thus we can obtain the Lagrange's equation of a motion. See this, there are three equations: Lagrange's equation of a simple pendulum, Lagrange's equation of a motion of a etude machine, and third is Lagrange's equation of a motion of a compound pendulum. You must know all these three equations, all these derivations perfectly. ओके, हे सर्व तीनही जे सिंपल पेंडुलमचं आहे, एटूड मशीनचं आहे आणि कंपाऊंड पेंडुलमचं आहे, हे तिन्ही थेरम, हे तिन्ही लॅग्रांजेज इक्वेशन ऑफ मोशन तुम्हाला परफेक्ट माहीत पाहिजेत. ऑब्जेक्टिव्हचा जर विचार केला तर डायरेक्ट आन्सर सुद्धा तुम्हाला परफेक्ट माहीत पाहिजे. ऑब्जेक्टिव्हमध्ये तुम्हाला कुठलंही विचारू शकतील, विच ऑफ द फॉलोइंग इज द कायनेटिक एनर्जी ऑफ अ कंपाऊंड पेंडुलम. फक्त फायनल रिझल्टच नाही, हे सुद्धा विचारू शकतात. विच ऑफ द फॉलोइंग इज kinetic energy of a compound pendulum, which of the following is a potential energy of the compound pendulum. That means each and every term you must understand, then you can write. Okay, तर आज आपण आता उद्याला आपण नेक्स्ट बीट सुरुवात करणार आहोत. उद्यापासून आपण नवीन बीट्स घेणार आहोत. त्यामुळं आज इथं थांबू, कारण आता वेळ कमी आहे. नवीन बीट म्हणजे परत त्यामध्ये डिटेल माहिती असते. This is the very interesting, classical mechanics is actually very interesting paper, but you must understand each and every concept. प्रत्येक concept तुम्हाला समजली पाहिजे. ओके, this is the applied paper. ओके, तर काही अडचण नाही आहे तुमची सर्वांची, त्यामुळे आपण इथं थांबू. उद्याला भेटू. नमस्कार, गुड बाय.